heard a lot. So my name is Tkaczewski. Thank you all for coming. I'm the president and co-founder of FileCatalyst. We have a stand right here at the show, G32. And we specialize in moving big data, transferring or shifting large data around the globe. So, very interesting question. There's a lot of solutions out there that propose to store your big data, to mine it, analyze it, search it, but not a lot of people are interested in moving their big data. And one big thing is that big data is not created on a single system. It usually arises from many different places, geographical locations. It can be coming from your branches, and big data is heavy. You can move it with using a hard drive or ship a disk, or is there a better way? That's where we are here today. So, just in a nutshell, what we do, we provide, large files. So we come in where, standard managed file transfer solutions and standards like FTP, SFTP fail. So if you want to move, gigs or terabytes of data from London to LA, for example, this is where we can help out. We can accelerate it, make it more reliable, and make this process manageable. So you don't have to, ship media anymore. We try to do this with, we try to provide you also all the tools to transfer all these files. So we're not only giving you acceleration, but we're also going to give you the file transfer tools. So for automation, for scheduling, so you're getting the full tool set of what we do. And the integration into the existing enterprise infrastructure is also very important. So, integration with your LDAP, Active Directory, antivirus. So these are the type of problems we try to solve, and we try to have as little impact as possible on your existing infrastructure and your current workflows. Another big thing where big data, people push big data to is clouds. So think of an Amazon cloud, or Stack. All of this requires, first there's a question: how do I get my big data there? And then how do I retrieve the big data from the cloud once I've done some processing on it? And once again, this is the type of applications we solve. So let's go back to the basics, or I'll just try to explain you why we're faster. Because the biggest thing here we do is we make the file transfer go much faster. So let's talk a little bit about FTP. So FTP is built on a protocol that all of you probably know. It's called TCP. TCP is the main protocol for all the internet traffic. TCP is responsible for all the internet traffic in the world today, including FTP, SFTP, Samba. So anything you're using today uses TCP. It's been around for over 30 years. It's a reliable protocol, but it was not meant to ever move big data. So what happens is that when I send something with TCP, let's say I'm going to send you some files here, and I'll send it to the data. I'm going to ask you, did you get it? You're going to respond, yes. I'm going to send you some more data. You're going to respond, that you got it. So as I'm sending files to you, I'm waiting for your acknowledgements. And now we're sitting in the same room, so you can just nod your head and say, yes, I got it. But the problem is when let's say you're across the hall or you're outside. Now the communication is slower, and that's what we call latency. So the latency on the network is that's what slows down the TCP traffic. So what the latency is usually measured in milliseconds. So I'll give you an example. To transfer a file from London to within the UK, you're looking at 40 milliseconds. This is how long a packet of data takes to go and go back. But then if you want to transfer the same thing to test going to, let's say, from London to LA, now we're talking about 200 milliseconds latency. So you can see that it grows. And TCP slows down dramatically as the latency increases. So what we did, we built our own UDP-based protocol. So imagine we're now sending data as fast as possible using UDP. Everything arrives very quickly, but UDP is not reliable. Its main practice is not reliable. So we've built a very efficient algorithm to keep track of what arrived and when. So you as a receiver, now I'm sending you data, and you as a receiver can say, oh, I'm missing, packet 14. So you tell me this, and I recite to packet 14. So like this, we keep everything reliable and flowing nice and fast. So we maintain the characteristic of UDP without the annoying part of losing data, the data being lost. So another thing that we do, because now we're transferring everything UDP, we can transfer a lot of threads and a lot of CPUs. So it's a very good protocol for multi-core architecture, where you have computers these days have multiple cores, are pretty fast. So this allows us to really maximize the bandwidth up to 10 gigabits through that multi-core architecture that we developed. It's basically every thread sending file, the UDP packets on the right, and everything arrives very fast. You can take advantage of distributed systems very easily with that. So what are the speed needs? Why is this so important? Well, here's some examples. This is North America to North America, as I mentioned, it's about 40 milliseconds, 40 and 60 milliseconds latency. FTP throughput, in this case, from a 45 megabit line, is maybe about 6 megabits. So, of course, if that 40 milliseconds becomes 0 milliseconds, which is a perfect world, but unfortunately we don't live in a perfect world, then FTP will be going just as fast as FileCatalyst is, but because there's that latency, FTP slows down. The problem's even more dramatic if you go to North America to Europe. Now we're looking at 200 milliseconds latency, and the speed of FTP slows down even more. So you can see how much bandwidth each of these examples recovers just by having a new, efficient, new latency protocol to transfer files. So what it translates to real time, because we all want to save either time or money. Time is money. So here's some examples, some real life examples we've done with our clients. LA to Hong Kong, 250 millisecond latency. FTP takes about 44 hours to transfer a 6 gig file. We do it in 20 minutes. You take LA to Auckland, which is once again RTT of 200 milliseconds. The speed improvement is 110-fold. So these are sort of real scenarios of what happens. We don't accelerate the speed, but we give you the full available bandwidth regardless of network conditions. So that's our UDP protocol, which is all of one optimization. Companies will do that. This is something that is known in the industry. We also do other acceleration methods. For example, we have rsync built in. So you send a 6 gig file, a little portion of it changed. We can calculate the deltas and then send just the little changes. So we're minimizing how much data is going to be sent over the wire. Another one big thing is, let's say you have a lot of smaller files. Let's say you have 6,000 1 meg files. If you want to send this, well, now what we have to do, we can put them all into an archive. Imagine a zip file that we're just building on the fly, and as this file is being created, we start sending it right away. We don't have to wait for the whole zip file to be created. We send it, and then we decompress the zip file on the other end, and the files appear instantly to the user. So to the user, you never really see all of this that's going on in the background, but that's another acceleration technique we can use. And then we can also transfer multiple files at the same time. Once again, if you have a large folder structure or multiple files to send, doing concurrent sequence transfers will also speed things up, because as I'm sending one, let's say, 6 gig file, and there's another small 10 meg file sitting next to it, well, both of them will go at once. The 10 meg file will appear instantly, so everything appears very quickly to the end user. And then we have compression. Of course, compression works to a certain degree. Someone uses, for example, video files that are compressed, and that might not be as efficient as doing database files or SQL logs. So compression, but the compression is built in, and once again, it's all transparent to the end user. Another type of compression we also have is LMZA. It's a high CPU intensive compression that is much better, more efficient than zip, but just require more hardware. But once again, as the user, you can make a decision do I buy more CPU or buy more bandwidth, which one is cheaper? So, besides our UDP protocol and all these other methods, here's sort of a real life scenario of how much we can speed things up on the transfers. So here's a directory structure, 7,000 files. It could be a disaster recovery, backup files, removing production data, whatever you want. There's 110 milliseconds latency. It's a 1 gig line, so it's sort of east coast of the United States going to Europe, Western Europe, that gives that latency. And we have one large 1 gig file, 8 large 500 meg files, 400 meg files, and a whole bunch of little files, 6,888 small files. So if we just use regular UDP, which some of the one acceleration companies do there, and other file transfer companies might do just regular UDP, you might get 141 minutes to transfer this file set. If you throw in our multi-client into this, that means we're actually going to do multiple connections at the same time, we can reduce this time to 14 minutes. And if we actually enable our auto archive or the zip chunking feature, we're getting down this to 1.5 minutes. I was trying to put a regular FTP without one acceleration, so I just wrote there in the text at the bottom. It was taking 21 hours. I just couldn't get the scale to work, but it's just gives you an idea how much speed improvements you get. So another part of accelerated transfers is that we want the bandwidth. We want to maximize your bandwidth. We want to send as fast as your line is. But we want to kill all your traffic. We want to be nice to your traffic. So, for example, if you want to, do some VoIP, or you want to browse the internet, or you want to have another TCP connection coming in there. So the key here is that we want everything online to appear slow, because we want to maximize the bandwidth, but we don't want to kill everything. And that's what congestion control does. And we're built in that, out of the box, you're going to get up to 1 gigabit acceleration with fairly fair network sharing across other TCP connections if they encounter any transfers. That will be slow, but that's the whole point. You want to maximize your network. You don't want to. That's why we're doing the acceleration. So some of the characteristics of our congestion control is that we're very quick to slow down and speed up if something else comes on the line, and we're fair to TCP connections as well. So that's important to know as well. Security. This is something that, because we're moving data, it could be personal data, it could be highly sensitive information. So we have a number of security features. The biggest one is SSL on the control channels and the AES data. So I just wanted to give you everything is encrypted and secure when you transfer. And then we have authentication capabilities. You're held up Active Directory. You want to manage your users centrally. And then we have the monitoring tools as well, where it will tell you if there's something happening in the system. So where is all of this useful? So first of all, you have to think of it in terms of general IT. So the biggest one and the biggest use case that comes under on the show here is disaster recovery and backup. So you have a large file set, you want to move it to a totally different physical location, perhaps even a different continent to maintain your business continuity. This solution is very fast and effective at this. Another one that comes what the users want to very often do is send heavy email attachments. How many times users, put in, 100 or 400 meg file through email and something to go through. So we have a software solution that allows you to attach large files and just email and download them to the user. And the acceleration, all this little thing in the background I explained to you, works with it. So the user just clicks on a download link, selects where it says save the files within their web browser, and the files are saved and the acceleration happens. So all of this to the user is transparent. They don't see all the things that happen in the background. Cloud deployments, once again, problems getting data. The first problem is getting data to the cloud, and then it's how to get it back out of the cloud. So that's we can work with that. And ranges of general FTP with one accelerators. Once again, those will speed things up. Maybe not as much as we do, but they will. But you're not getting any tools. You're not getting the management tools. You're not getting the audit tools and security. So you're getting all the managed part of the accelerated file transfer with our solutions. Certain verticals can use this more than others. I just wanted to outline, broadcast media. Lots of customers moving large video production files, either to broadcast, post-production, archival, transcoding, and military law enforcement. That's communication with the fleet is the biggest one we've seen. Clients need to push data to the ships very quickly using satellite connectivity. That's one. And another one is intelligence data, so any kind of video surveillance again, audio files, video files, and as well as mapping data. So if there's the mapping bureaus are not necessarily always deployed with the units, they stay behind, and everything is done usually from the country of origin, and the maps are then the large maps are just shipped to the theater. Oil and gas, needing seismic data, that's another big one. So imagine ships are capturing a lot of big data. Want to move that data, from a ship or an oil rig back to the central location. This is where the big data comes in. And already the wellhead operations. Once again, these are all massive files being created, and in a very wild freeze networks. This works really well. So we developed a number of solutions. The solutions kind of answer to specific needs. For example, our FileCatalyst Direct is a point-to-point. It's a direct point-to-point file transfer. So if you want to move files, automate file movement, replace FTP, that's the solution for it. Workflow and webmail are more like a web-based portals. So if you want to do, send a file to an email address by just sending a link of the actual file, that's the web-based product. There's also a web-based folder or like an online Dropbox capability built into these products. So you can take all this software, install it all internally, manage all your data. Manage all the data on the servers remain within your control, but you can provide a very user-friendly and clean application to your enterprise users. Central is our management, as I mentioned. So imagine you have FileCatalyst server deployed, a whole bunch of hot folders sending data to a central spot. You might have workflow deployed as well, and then you want to see it all in one spot. So this gives you that management. And very quickly you can identify where the bottlenecks are. Let's see, our connection between New York and London is small. You can see it very quickly, identify it, and react to it. And then we have the cloud solutions. So once again, our approach for the cloud solution is to, our software will work on any cloud-based platform, whether it's Amazon, Azure, OpenStack, or any other cloud vendor that you may wish to work with. and we can provide you with the installation files, you can deploy it, and you can then use this to push data to the cloud or take data from the cloud. Just to give you a summary of what we do. So we transfer files, we transfer big data really fast. We use a number of tools besides just using the acceleration. We're the only vendor so far in the market that can do up to 10 gigabits. So we do have actually proven not only tests by other independent test labs that show that we can do 10 gigabits on the WAN, but also we have real users transferring data from the UK to the US on the 10 gig private line, maintaining the full 10 gigabits. Our solutions are fairly modular. As you can see, our products are kind of separated on what you want to do. You can get into the technology fairly quickly, and the cost is not high, and we can build as a workflow and use cases increase. You can add on functionality later. We're at the booth here, G32. If you have any questions, we'll be happy to answer them. And we have monthly webinars if you are interested in moving big data. We have webinars, newsletter as well. You can sign up if you're interested. Come by our booth and we'll sign you up for our newsletter. And a lot of the webinars go on our YouTube channel. If you want to watch the latest news on how to move big data on the internet. I have a few minutes for questions, so anything. We use UDP. I already answered that earlier, but we use our own UDP-based protocol. But the protocol works in any files. There's no difference whether it's a SQL, a binary file, a video or an image or audio. It doesn't matter. We work from the file system. We work in any file from any file system.